patch clamp.
Patch clamping.
Because you're patching the cell with this pipette.
Ah, that's brilliant.
And so the member that is within the pipette is a patch.
Yeah.
Below the objective, so I can start looking for my pipette again. Oh, sorry. Because I need to find it on the screen, otherwise I won't be able to approach the cell. There you are. So you can see it on the screen now.
So that's your needle
Yes.
approaching the cell. Where have you put it into in the cell?
Where do I put it?
Yeah, where do you?
So you will see I
place
will
it?
approach the cell and I will just touch it.
Okay.
So I want to create a seal between the pipette edge and the cell member.
Okay, so just the cell body, so you don't go near the axon at all?
Yeah, mainly it's the cell body. But there are people patching also the axons, the dendrites.
Okay.
But that's a very fine patch clamp. So now I just scroll down until I will reach the slice. Almost there. So now I will position to check where my cell is again. So the pipette has a positive pressure that I applied. So you see the tissue gets moved out when I'm entering.
Yeah.
Alright.
You're just touching it,
Yes.
and then you're going to apply
Negative
current.
pressure first. Because I want to get really close to the membrane, and then I apply a suction. So now let's see if we get a seal. So theoretically
So it's
these
like a
lines.
suction, that kind of
Yes.
locking on.
Now hopefully we will get it. So the cells are pretty old, so I'm not sure we will get it, but we'll see. Okay, it's getting up. And let's see if we get it.
Are you recording this as well, like on your machine?
So for now I'm just recording live.
Yeah.
But once I get the seal, if I get the seal now, then I will start doing recordings.
And what are you going to be recording?
So, for example, since we are waiting for this, I can show you what I could get. So this is, for example, what you can have when you patch a cell. In this case, for example, I'm applying a negative current. So I start with the protocol where I gradually increase the current that I'm injecting in the cell. And so you see it, the membrane potential changes in the cell. Goes to zero, and then it starts getting positive until the cell starts firing. And the more current I inject, the more the cell will fire.
Is that the firing there?
Yes.
Oh.
So this is all, each one is an action potential from the neuron,
Nice.
which is firing. So the more current I inject, the more firing it will be. So now I want to create a physical connection between the inside of the pipette and the inside of the neuron.
Yeah.
So I need to apply another suction, but very quickly.
Yeah.
And we have this mouthpiece, so we need to apply it.
Oh, wow.
Oh, really? That's like a
Yes.
glass blower.
Yes, pretty much. It's
Yeah,
the same.
yeah,
but
yeah.
it's negative in the end, so you apply suction. We call it like a kiss because you have to really try to.
Oh, I'm glad we got this bit.
If we manage to open it. Sometimes it's a bit difficult.
So that pressure is pushing through the cell wall? Or what?
Theoretically, what I'm doing is to try to suck out the piece of membrane, the cell wall that is
Yeah. So
inside just here.
puncturing it.
Yeah, pretty much.
So that, yeah.
But you still try to keep the connection
Right.
with the pipette wall.
This is Just like when I do a join in borosilicate glass.
But it doesn't want to open.
No.
But we can try another way. So if you don't get it by mouth, I also try with the syringe. So pretty much the same way. You just
Yeah.
apply negative pressure. It just is a little bit more violent. So sometimes you risk to lose the cell.
So where can you see that it's been successful?
If it is, then you will see some current popping up
Okay.
over here.
Yeah.
Still nothing.
This is where you think because of the cell's age that it's
Yeah.
having difficulty?
Yes. This has been 5 hours now.
Oh, it's tired.
Yes.
Tired and listless. Oh,
There you are.
it's done it.
Yes.
That's what you're after, yeah?
Yes.
Mm.
So now.
And can we see it here? No, it's only
Uh,
on an
no,
electrical
that's too
kind of
small.
signal, yeah.
So now I just want to stabilize it. So I apply just a little bit of suction here so that it stays a bit more stable. So I'm looking at the cell. Then I had to compensate for all of these currents that you see here so that I can record really what is inside the neuron.
Ooh, I like that bit.
Then I change because I want to start with current clamp first. And then I can start recording them. So now you can see it firing.
That is so beautiful. Isn't that amazing? I love that.
I've heard so much about patch clamping in my life, but I've never seen it happen. Which is pretty
You're
Yeah.
running it again?
Post-op, yeah.
So each one of these is an action potential.
Can you show us, like, can you tell us, like, what that graph shows us, though, like, for a lay person?
Yeah, so we are measuring the membrane potential while we are applying a protocol where we inject current to activate the neurons. So the neuron, like
What is
the
it you're injecting in?
current. So it's like
Current, the electric current,
the
yeah.
electric current.
Yeah, yeah.
But at the same time, you are measuring the membrane voltage.
Uh-huh.
So it's
But we're talking absolutely infinite, like tiny, tiny
yes,
currents.
yeah. So here we
Is
are
there an
measuring
analogy,
millivolts.
like, what the
Yeah.
equivalent would be? Like, you just
Oh, it's
don't know
nothing.
what it
So if you have milliampere, so it's tens of thousands less than a battery in the end. It's really, really small.
is. Just a really tiny thing. And what we're seeing there, in that beautiful kind of forest of signals that you've recorded.
Ah, yeah, so each one of these that you will see, I can run this other protocol. So it will be one single action potential.
Yeah,
And
each line is.
Yes,
yeah.
each line is where I'm injecting my current. And it is long enough that you have multiple action potentials. So that's what we have here.
That's-
And so what is this telling us?
So what I want to know from here is what is the firing frequency that I can have. So how many action potentials I will see while I'm injecting my current. And these can be different depending on the neurons that you're looking at. So I'm trying to look at two different neurons which have different properties for this fire.
Okay. So you're characterising them
Yes.
according to how they respond.
Now I go for a single action potential, similar protocol, but I'm injecting for a shorter amount of time because I want to see single action potentials only. So this is more to look at the characteristics of the single action potential, the shape, the kinetics. So I need to run also this one.
And is there a drastic difference between cell types and how this profile looks?
There can be, so the single action potential can change depending on the function of the cell, the state of the cell. The firing frequency is mainly of about the kind of cell. So that's what I use it for. So I have D1 neurons in this case, which fire way later. They have a higher threshold. And then D2 they have a lower threshold, so I have to inject lower current to generate the fire. So it is different in that sense. Also to record potassium currents, which is this steeper curve over here, and look at the potassium currents happening. And then finally I will record spontaneous synaptic activation.
Oh, that's right up my street, that one.
Yeah, that's right up your street.
That's my kind of thing, the spontaneous ones.
So hopefully I will still have some activity because really the slice is a bit old.
Even though he's got a bit tired.
Yes.
Been firing away.
Knackered.
Really firing on, you know.
So I'm not sure we are going to have some, but we'll see.
How many can they connect with at once?
It can be hundreds, thousands, depending on the neuron.
Yeah.
Certain the neurons they are very ramified, so they receive more input. In this case, I think it's less ramified, so you don't have too many. But still very important. And then you start looking at them. That's another event here.
And
That's another one.
the sort of longest time period that you might look at that?
Yeah, I'm recording for 5 minutes. So now he went to the third one of this protocol. And so now I'm waiting 1 minute, then it will be the next one. So 5 of these ones for 5 minutes. And then theoretically I'm done with this neuron. And I'm probably done with this slice as well. Because
Okay.
this was
Sure.
he's starting a new protocol now. So maybe here, yeah, these are other events. So 1, 2, 3, 4, 5. And so with this one we look at the frequency of these events happening, the amplitude, just to see the strength of connectivity between the neurons.
Okay.
So this is what we have here. So for example here, so you can see over here, this is an excitatory postsynaptic current that I recorded using this program. And so along the time, each neuron can receive several of those. So for example here you can see there are others. Here. There are others in here, here. So this one is like the current generated from one connection with another neuron.
You see the lamp right here.